Find the rank of the matrix 1, 2, 3, 0, 2, 4, 3, 2, 3, 2, 1, 3, 6, 8, 7, 5, which is a repeated problem in examinations. Okay, right? How can we find the rank of this matrix? Let capital A is equal to the given matrix 1, 2, 3, 0, 2, 4, 3, 2, 3, 2, 1, 3, 6, 8, 7, 5. What is the procedure? First of all, you have to take this element and make these three elements as 0. And then after, take this element and make these two elements as 0. And use this element and try to make this element as 0 by using elementary row operations only. In echelon form, we have to use only elementary row operations and try to make it in echelon form, which I have already explained that if any 0 row is there, that should be in the below of non-zero row, and if the number of zeros of first non-zero element in any row should be less than the number of such zeros in the next row, which means if suppose this is 0 and these two must be 0, because the number of zeros before the first non-zero element is 0 here, 1 0 here, and the number of zeros of first non-zero element in the next row will be these two. These two must be 0 by the definition, and for this one you have to make these three elements as 0. That means the number of such zeros. So if suppose I am using this element and make these three elements as 0, and use this element, I will make these two elements as 0, and use this element and make this element as 0, which is an upper triangular matrix. We may say that, but not exactly. So if you make these two elements as 0, the number of zeros, how many number of zeros are there for the first non-zero element? One element. And how many number of zeros in the next row? Two zeros will be there. Here it is only 1 0, and in this one you have 2 zeros, and in this one you will have 3 zeros. That means the number of zeros before the first non-zero element of a row should be less than the number of such zeros in the next row. So the 1 less than 2. Here is only 1 0. Here you will have 2 zeros and you will have 3 zeros. Okay, I think you got my point. Now let us solve this problem. Let us make these three elements as 0 by using elementary row operations. Now how can we make these three elements as 0 by using row operations? Here 2 is there, and you can multiply this one with 2 and subtract from this row. That means I am writing the elementary row operation as R2 tends to R2 minus 2R1. Here R3 tends to R3 minus 3R1. That means you have to multiply the first row with 3 and subtract from third row. 3 minus 3 will be 0. Similarly, R4 tends to R4 minus 6R1. That means you have to multiply the first row with 6 and subtract from fourth row. 6 minus 6 will be 0. What is the resulting matrix? Let us say which is equivalent to, there is no change in the first row because you do not have applied any elementary operation on first row. So it is as it is. 1, 2, 3, 0. 2 minus 2, 0. 4 minus 4, 0, because I am multiplying this one with 2. 2 minus 2, 0. 4 minus 2 into 2, 4. 4 minus 4, 0. 3 minus 3 into 2, 6. 3 minus 6, minus 3. 2 minus 0, 2. Now coming to the next elementary row operation, R3 minus 3R1. R3 minus 3R1. You have to multiply this row with 3 and subtract from this row. 3 minus 3, 0. 2 minus 6, minus 4. 1 minus 9, minus 8. 3 minus 0, 3. And coming to the last elementary row operation, 6 minus 6, 0. 8 minus 6 into 2, 12, minus 4. 7 minus 6 into 3, 18. 7 minus 18, minus 11. Five minus 0, 5. This is the resulting matrix. Now you can observe that here there are two zeros, and but here only 1 0 in these two rows. According to the procedure of echelon form, the number of zeros before the first non-zero element should be less than the number of such zeros of next row. Here these are the rows containing only 1 0 before the non-zero elements, but this is the row containing 2 zeros before the non-zero element. So this row must be in the third row and this row must be in the second row. So I am interchanging R2 and R4. What will happen? You may observe. R2 if and only if R4. So this is equivalent to, so let me take a line here, which is equivalent to no change in the first row, 1, 2, 3, 0. And R2 must be R4. That means 0, minus 4, minus 11, 5. 0, minus 4, minus 11, 5. And third row, 0, minus 4, minus 8, 3. 0, minus 4, minus 8, 3. And R4 will be R2. 0, 0, minus 3, 2. 0, 0, minus 3, 2. Now you can observe that the number of zeros before the non-zero elements will be less than the number of zeros in the next row. Now you have to make this element as 0 by using this one. Actually you have to make this one also if it is non-zero. But you observe that this is already 0. So we are lucky that you can apply only one elementary row operation. That means you can make this one as 0. How? Simply you can subtract R2 from R3. R3 tends to R3 minus R2. Then this element will be 0. So R3 tends to R3 minus R2. What will happen? No change in the first row. 1, 2, 3, 0. No change in second row also. 0, minus 4, minus 11, 5. Now 0 minus 0, 0. Minus 4 plus 4, 0. Minus 8 plus 11, minus 8 plus 11, 3. 3 minus 5, minus 2. And no change in R4 also. So 0, 0, minus 3, 2. Now you have to make this element as 0 by using this one. This is the procedure I have already explained, that use the first element and make these three elements as 0, and use this element and make these two elements as 0, and use this element and make this one as 0. So here is the case. We have already applied the elementary row operations and make these three elements as 0, and next you use this element and make these two elements as 0. Already this element is already 0. Now simply you can make this element as 0, and then after use this element and make this one as 0. That means R4 tends to R4 plus R3. R4 tends to R4 plus R3. What will happen? It is equivalent to no change in first three rows. So 1, 2, 3, 0. 0, minus 4, minus 11, 5. 0, 0, 3, minus 2. 0, 0, minus 3 plus 3, 0. 2 minus 2, 0. Now let us calculate the number of non-zero rows of the obtained echelon form. This is in echelon form. This is in echelon form. This is in echelon form. How many number of non-zero rows are there? 1, 2, 3. Therefore, rank of A is equal to 3. For the given matrix, rank of A is equal to 3. This is the way how to find the rank of a matrix by the concept of echelon form. I request all of you, please like, share, comment and subscribe my channel Balaya Math Lectures Learn Every Step. Thank you.